Okay, we want to find all the critical values for this function, f of x equal 4x over x minus 3. So I'm going to start by finding the derivative. F prime of x is going to be equal to, okay, I'm going to have to use my quotient rule here. So it's going to be the denominator, x minus 3, times the derivative of the numerator, and the derivative of the numerator would be 4, minus the numerator 4x times the derivative of the denominator 1, all that divided by the denominator squared. So I have x minus 3 squared. Okay, I'll simplify a little bit in the numerator. So I end up with 4x here minus 4x here, that's 0. 4 times negative 3, negative 12 over x minus 3 squared. So here's my derivative, and I need to look at the derivative and see where the derivative is 0 and where it's undefined, and those will give me my critical values. So when I look at this, undefined, when x is equal to 3. So I might think to begin with that that's a critical value. But look, when x is equal to 3, my original function is undefined. So for a number to be a critical value for a function, that number has to be in the domain of x to begin with, and x equal 3, even though it makes the derivative undefined, also makes the function itself undefined, so it's not in the domain of the function, so we can't use it. So in this case, no critical values. Okay, so let's go to the computer real quick and look at our Desmos graph and see if what we get for the graph makes sense on this. So let's take a look. Okay, here's our Desmos graph. So I'm going to put in the equation y equals 4x over x minus 3. And you can see there we get a graph that looks like it goes off to infinity, both up and down at x equal 3. Let's go into this and zoom out a little bit. Sure enough, we have an asymptote at x equal 3, so I'm not going to get a critical value of that value of x. So our graph does sort of reinforce what we found algebraically by solving for that critical point. There's not going to be a critical point at x equal 3.